Hi, this is Sung. I'm the director of Sky Academy, and we've been looking at plane geometry, and we've been going through proving different, we've been, asserting different axioms and showing why they're true, and also proving different theorems and showing why they're true as well and proving them. In this episode, what I want to do is do another theorem yet again, and it's got to do with parallel lines, and it's called the equal intercepts theorem. Okay, so let me just go through the premise of this theorem. So this is what the theorem says. If the intercepts cut off on one transversal by three or more parallel lines are equal or in a given ratio, then the intercepts cut off by them on any other transversal are also equal or in the same ratio. Now, I've written the word the twice, so let's get rid of one of the. But let me just explain what I mean by this. So if the intercepts cut off on one transversal by three or more parallel lines are equal or in a given ratio. So in other words, if you've got three or more parallel lines, 1, 2, 3, see how this line's parallel to this line is parallel to this line? So we've got three parallel lines, and you've got one transversal, right? And that transversal is cut off by those three parallel lines, so that you've got one intercept here and another intercept there, right? And they're in the ratio x to y, okay? Then, if you've got a second transversal, right, and it could be at a totally different angle, like this one is, then what you will find is that the three parallel lines will again cut the second transversal in the same given ratio. So the ratio of this d to e to f will also be x to y. Okay, so whatever ratio this is in will be the same ratio that this is in, simply by virtue of the fact that these three lines are parallel. Got it? So we're going to set out and show that this is true. All right. So when it comes to this proof, here's what we've got to try and prove. So the aim of the proof is to prove that the ratio of DE to E to F is also the same as the ratio A to B over B to C. And that ratio is X to Y. Got it? So we're trying to show that this over this is equal to this over this, which is X over Y. Okay? So we're just trying to prove that. Here's what we're given. All right? This is the information that's going to allow us to work with and work towards showing this proof. All right, so we've got three parallel lines. Right, the first one's AD, BE, and CF. All right, so you've got three parallel lines, AD, BE, and CF. You've got two transversals. You've got AC, which passes two transversals, AC, which gets cut by the second parallel line at B, and DF is a second transversal which gets cut by the second parallel line at E. All right, so AC is cut at B such that AB over BC is equal to X to Y. All right, so in other words, we know the ratio of the first line. The ratio of the first line is X to Y. Okay, now if we were to try and show that they're equal, right, so that this intercept and this intercept are equal, then we just have to show that X equals to Y. All right, so by virtue of the fact that we're showing two different values, X and Y, right, we can actually work out when they're equal by making X equal to Y or Y equals to X, right? So that's easy enough. But what we're trying to do at this stage is basically work out that they're in, so if this is in one ratio, then this will be in the same ratio. So that's what we're setting out to prove. And if we can prove that, then we've automatically proved that if these two are equal, then these two are also going to be equal because they're in the same ratio, okay? In the ratio of 1 to 1. So let's hammer this proof out, and I'm going to show you how I'm going to do this, right? Basically, here's my proof. So what I'm going to do is construct two other lines, right? I'm going to construct D to G, and I'm going to construct E to H, right? So DG and EH. And the way I'm going to construct that is I'm going to construct DG parallel to AB. And I'm going to construct EH parallel to BC, all right? So I'm going to construct interval DG so it's parallel to AB, construct interval EH parallel to BC, all right? Now, what that gives us is a parallelogram here, okay? So in quadrilateral ADBG, you've got a parallelogram. And the reason why it's a parallelogram is because you got one set of parallel lines here and another set of parallel lines there. Does that make sense? Right. Let's have a look. Let's make that double parallel. And in quadrilateral BECH, you've got another parallelogram because these two lines are parallel to these, these two lines are parallel and these two lines are parallel. Got it? Okay, so that's basically going to be my first line of my proof. So let's do that. So basically, here's what I've done. The first two lines of the proof are quadrilateral ADGB is a parallelogram, okay, and I told you the reasons why. Because the two opposite sides are parallel. The two pairs of opposite sides are parallel in both in both quadrilaterals. So both quadrilaterals are parallelograms. Okay, so that basically allows us to do something else. So now that we've worked out that these two parallelograms, these two quadrilaterals are parallelograms, the next step here, all right, is this. What we're going to do is we're going to work out angle ABG and say that it's equal to angle DGE, which is basically this angle here, and I'm going to put a little star there, and that angle there. Does that make sense? We're going to show that these two angles are equal, all right? Basically, the reason why that they're equal, right, is their corresponding angles on parallel lines. Does that make sense? They're corresponding angles on parallel lines. Good. Now, the other thing that I want to show you is that ABE, which is the same angle as ABG, in fact, let's call it ABG just to keep it consistent. That angle there is also equal to that angle there. Does that make sense? Now, the reason why is exactly the same. They're corresponding angles on parallel lines. Yep. Which is also equal to that angle there. That angle there is equal to that angle there. Now, why? The same reason. They're corresponding angles on parallel lines. Does that make sense? All right, so the next step is this, and I'm going to call it step 3. All right? Basically, with step 3, we're trying to show that this angle here is equal to that angle there. Do you see that? That angle and that angle? Okay, good. So I'm going to show that by doing a little asterisk. All right, good. All right, so the reason why they're equal is exactly the same as the reasons I outlined before. They're corresponding angles on parallel lines. Got it? Good. All right. Now, what that allows us to do, right, is it then allows us to see that if these two angles correspond to these two angles, then the third angle must also be equal, right? So what we've got here is two similar triangles. Got it? And the reason why they're similar is that they're equiangular. Okay? So I'm going to write that up now, which is going to be step number 4. Got it? All right. So we're up to step 4 now, and I've basically shown, or I basically proved using similar triangles, right? And the fact that we've got equiangular triangles, that triangle GDE is similar to, and that's similar to HEF, right? So here we've got this angle being equal to this angle being equal to this angle, right? This angle be equal to this angle equal to this angle, which basically means that the third angle would be the same. You've got equiangular triangles, which means that they're similar. Does that make sense? So that's step 4. Step 5 is basically this. Step 5 is basically the ratio of DG to EH is going to be equal to the ratio of DE to EF. Does that make sense? All right. Let me just halt there for a second. So let me just write that down. All right. So basically what I've done is written that out. DG over EH equals to DE over EF. And the reason why is because you've got similar triangles. This triangle is similar to that triangle. So DG over EH is equal to DE over EF. Does that make sense? All right. But here's what I want you to know. DG is equal to AB and BC is equal to EH simply by virtue of the fact that you've got opposite sides in a parallelogram. Okay? So that's going to be our next step. Okay? Good. But so I've written here, but DG is equal to AB, which is equal to X, and EH is equal to BC, which is equal to Y, which basically means that X over Y is equal to D over EF. Okay? Which basically is the proof. All right. Good. So basically, you've got the proof here. You get the proof by substituting all of this into that. Okay? And that actually shows you or proves to you that this theorem is true. Okay? Good. That's basically what I wanted to cover in this episode. Thank you very much for watching.